then cool down. Like this it will happen. Another student, sir, uh, it will decrease like this. Tell me like who is right? Anybody? Can you support red color variation? It will not cool, then it will cool. It will not cool, then it will cool. Never, no. Or can it happen like this? Linearly decreases. We are not very sure. So let's go for temperature as a function of time, and let me discuss how that cooling affect temperature. So if I have a graph, temperature as a function of time, then I can interpret this graph, which is possible. Or it can happen like this also. It can happen like this also. It is also cooling down. So now what is the biggest thing is like all four graphs correspond for cooling only. Then how the temperature varies with the time, we are not sure. At least this red color is ruled out. Am I right? So will it be linear? Will it be some sort of curve like this, or it will be. So now I think now biggest problem is this three graphs. Okay, how to interpret now? This is what a big question, what we get it. So for that purpose, what happen? I'll just take thermometer, I'll insert it for every 10 seconds. I will note down the temperature when I plot it. No, when I plot that, it is not this, nor this, nor this. It will be green color one. Like that, the ordinary body will cool down. What do you mean by ordinary body? See again, don't think that something you should need a physics lab. That's why I just took example hot tea, finish over. How the temperature of this hot tea will vary with time. That is what Newton laws of cooling. Your mother will cook curry or sambar. Hot sambar will be hot. Then what happen? It will be kept open. No, let it be. So then what will happen? How the temperature of that sambar will decrease with the time. That is what Newton laws of cooling. Or hot water. How the temperature of hot water will vary with the time. That's what will be this. On what all parameters it depends. That's what we are going to learn. Okay, Newton's laws of cooling is something related to our kitchen. In kitchen, what happens? We do prepare curries, tea, all milk, everything will be there. How the temperature of that hot bodies will vary with the time. Studying of that is what Newton's laws of cooling. Okay, I'll come to this graph later on. In books, what happened? They just brought like a body of mass and specific heat. Again, students will think something imaginary. No, Newton's laws of cooling is related to the kitchen. Do notice, see, like so many things it happened no in front of you, we never noticed. And you want to become engineer from 8th 9th 10th, what happened? Your quest for to get IT rank started, but you never thought like, okay, something what I'm studying this IIT is something related to my day-to-day life. You never understood. You thought like something big, something you should be genius, you should have a research mind, you should have a scientific mind. Put all in dustbin. You make observation in kitchen, you will get a better rank. Instead of going for ITJ foundation for any schools, no, you should have made observation in your kitchen. Things would have been far better. Huh? Okay, got it? No? So at least now I'm telling so many examples. Please do understand. Huh? Okay, let's start with the discussion. So there's a body of mass M. Say students do think that JEE advanced means if you study, you should not understand. Wrong thing, no? There's no such a science where it is difficult. Only what will happen? Our attitude is a problem. This is a mass, M, specific heat, emissivity E. Let me give lamp black coating also. So some will think, sir, what it is. So some ordinary bodies, even this is also not needed just for, because I'll be writing E, no? Okay, we'll do one thing. I'll remove it, not needed. Huh? Okay, this is having emissivity E. Surrounding temperature is T naught. So what actually happens? It will radiate. It will emit better. So like it will be emit. At the same time, it will be also absorbing. Absorbing, I'll show only few colors. Now, as body is cooling down, so what do you expect? The rate of emission will be greater than rate of absorption. So how do we write Stephen's law? The power radiated by a body is equal to power emitted minus power absorbed. What is the power emitted? E sigma A T to power of 4. Let T be the temperature of the body. That power absorbed, absorptivity. What is the emissivity of surface? What is the absorptivity of surface? Sigma surface area of the body, let it be A. Temperature of surroundings T naught 4. For our convenient purpose, we are writing E equal to A. It need not. Don't think that for a given body, E must be equal to A for our convenient. For mathematical, for simple, or say for simple calculations. But there's no rule that E must be equal to A for any body. There's nothing like that. They're nowhere related. Emissivity and absorptivity what will happen need not be equal for a given body. So therefore, since E equal to A, so I'll take outside E sigma A. Okay, I get this. So till now, I think now we have to work out here. What is usually temperature of the hot tea? 60 degrees, 70 degrees. What is the temperature of surrounding 30? What is the temperature difference? Usually it will be very small, no? So what is the temperature of the body compared to surroundings? Usually it will be small. It will not be something very high. So what is the temperature difference between the body and surrounding will be very small. Will not be something very high, will be very small. So there is one assumption what T minus T naught, the temperature difference. Let me put it here. The temperature difference between the body and surroundings will be of order few tenths, means 30 degrees, 40 degrees, 50 degrees. So that usually that will be very small, will be of order few tenths. Okay, 30, 40, 50, 60 of that, not like few thousands, not possible, no? So in kitchen, any object is there where temperature of the object can attain 10,000 degrees Celsius, not possible, no? So there's a thing. Okay, let me proceed now with the mathematics. So therefore, this delta T, temperature difference, T minus T naught, will be very small. Not very small means not negligible, will be of appreciable, some few tenths. Okay, let me introduce this back here, P equal to E sigma A. So can I write this is T naught plus delta T to the power of 4. I'm introducing back in this equation. Try to see this. This T what I can write, delta T, T naught plus delta T to the power of 4. Okay, let me take T naught outside, E sigma A. Now, what is usually delta T? Delta T will be very small. So this total E sigma A T naught to the power 4, I'll take outside. Then this will become 1 plus delta T. Delta T will be very small. So therefore binomial expansion. Okay. I think some of, I'll just shade it. Try to notice this one. So from binomial expansion, it has become like this. Delta T very small. So I can go for binomial expansion. So this will become, the resultant will be P is equal to in the bracket, what will be left over? 4 delta T by T naught. One T naught get cancelled. So E sigma A 4e sigma a t naught cube delta t. Okay, this equation better remember. At so many places, this is going to help us a lot. At so many places, it's going to help us a lot. So what's happening to the body? It is giving out heat, no? So power, what we can write it as dq by dt. Delta T is temperature difference between body and surroundings will be of order of few tens. What is delta T again? Temperature difference. I'll write it. Okay, this is very important. The term, what is delta T? Temperature difference between bodies. So, okay, the body loses heat or gains heat. The body loses heat. So according to calorimetry, if a body loses heat, what we write? Minus ms dt. Keep it in this way. Okay, almost we have reached the end of this particular thing. This delta T, if you are getting confusion, call that as theta. Delta T as theta. Okay, let me here I'll write it. Not Q, theta. That's why small q I wrote it here. So this will become d theta by theta is equal to 4e say sigma by ms into dt. Let me integrate this. What should be the limit? What is theta? Theta is a temperature difference. Theta is a temperature difference. So what is the initial temperature? Initial temperature difference, let it be theta I. Final temperature difference, let it be theta F. This is the time taken. So what is theta I? Initial temperature difference. What is theta F? Final temperature difference. After some time t, what will be the temperature difference? Okay, this I would have used t only. Again, if I write delta t, t no, you'll get confused. Okay, these are some, for our convenient purpose, we have brought it. So this will become log of theta f by theta I, negative sign, I'll sign it here. So this will be 4e sigma a. Okay, this will be theta f. Theta or let's write temperature difference at any time t. Okay, no, so this will be, let me write like this. It'll be easy for us because more generalization we can do it. Now, shall we send this log on that side? It'll become exponential 4e sigma a. Already, I think equation of like this we have come across. So what is the temperature difference at any time t is equal to theta I. I'll write everything as alpha. So what is alpha? Alpha equal to 4e sigma a. It depends on all these quantities. Okay, let's come for theta. Theta is what we write temperature difference, no? So then can we rewrite this? Theta minus T naught, temperature difference at any time. Initial temperature difference, how much it will be? Temperature of the body, initially Ti, surrounding temperature will be T naught. So e to power of minus alpha T. Okay, let's write few things. What is Ti? Initial temperature of body. What is T? Temperature of body at time T. Now what is T naught? Temperature of surroundings. Okay, like this is what, can we plot this graph? Put t equal to 0. So this will be further. Put t equals 0, what will be the temperature? Will be Ti. So if you're getting confusion, T0 initial, you can write Ts, any of the symbol. Since in most of the Stephen's law, T0 is what surrounding temperature we took it, no? That's why I wrote it. Ti and this one. No. Uh, can we go for graph? Okay, the possible graph will be initial temperature Ti, temperature at any time t. So the curve will be like this, exponentially decreasing curve. Okay, the body, what happened? The graph will not be linear. In fact, it will be exponential decrease. Sir, how do you can say with the help of this one? Finally, how much it will become? That of the surroundings, T naught, after a long time. What will be the temperature of that hot tea? Will be that of the temperature of the kitchen. Like this, the body will cool down. Means initially what will happen? The body, according to graph, what will happen? Initially, the body will be in a hurry to cool down. So the temperature will decrease rapidly initially. After some time, what happen? It will lose interest in cooling. If the curve were like this, if the curve were like this, then what you would have said? If the curve were in this way, how you would have interpreted? For equal change in, for equal decrease in temperature, there'll be equal increase in time. Means like if in 1 minute temperature falls by 2 degrees, in next minute again it will fall by 2 degrees, but here not like that. Initially the fall in temperature will be more. You can see that one. All of you, I think you should know how to interpret a graph. If it were like this, the rate of change of temperature would have been fixed value. But what about here? The slope here is more and here it will be less. Don't interpret negatively, only magnitude I'm asking. The slope here is more, here is less. So initially what happened? The rate of cooling initially will be more and gradually it decreases. So what is the body now? The body initially will have more interest in cooling. Afterwards, it will lose interest in cooling, just in terms of common language. Or rate of cooling initially be more and later on it decreases gradually. You can see here. So how to interpret this graph? How to interpret this graph? So what uh, they suggested, like how to interpret this graph. So what you do is like take help of. So the curve is like this. So you do one thing, take two equal intervals of time. Say interpret, how to interpret a graph means students will only look at. So you should take what you should do. Either you draw horizontal line, either you draw vertical line, or else what you should do, or else what happen? You what happen? Compare the slope. Something you have to do it, not just only looking at graph. Okay, look at now this. It's very clearly visible for you now. So what is the temperature difference here? It will be more here, no? For equal intervals of time. What will happen to temperature difference? Here what happen? The rate of cooling here more. The temperature for the temperature of body decreases more initially than no. Able to get this one? This is a time. This is a temperature. Temperature of what? Temperature of body. Temperature of. Okay, if you just take two equal intervals of time, the initially the rate of the fall in temperature will be more. The difference in temperature will be more than this one. Or you do one thing. You can also interpret graph like this. See, actually, that's what I'm telling the students will not analyze. They don't want to put pressure on their brain that one. They just want to see information like how we watch movie. No, the science and technology has become like that. They want to just gather information. Interpretation of graphs, take scale, pencil, draw horizontal. Whenever you get a graph, what you should do, draw horizontal lines, vertical lines, or a slope or area. Four things is what you can do with graph. No, do that. Something information you can gather it. This you're not doing. There's a major problem. Huh? Okay, now let me take the equal temperature difference. Actually, as a teacher, I should not show this, to be frank. Teachers should not teach this graphical analysis because already it was introduced for you. But still, you think that what we did earlier, it was first chapter. Now this second chapter. In second chapter, again, the graphs will be different. Okay, now look at the green color curves. I'll bring it. Black color will take it. Yeah. Can you say anything about this one? For equal change in temperature, what about the time taken? Initially, it will take less time and finally take more time. So this is delta T, you write it. Same change in temperature. What about here? For same temperature difference, what happen initially? It will take less time for the for the decreasing temperature. Afterwards, it will take more time here. So therefore, how the body will cool. Initially, what happen? The rate of cooling will be more. Shall I use word rate of cooling? Slope will be more, and gradually it decreases. So what's happened? The body will be more interested initially. Okay, let me cool down. Let me cool down. Let me cool down. Afterwards, it lose interest. Like same thing happened for the moment in the month of April came, you were so excited. Okay, JE advance, everything okay, finally we'll take admission in this particular college, then teacher will come and teach, will get a knowledge, will get a rank. Gradually what happened, you came to know that not by intuition, not by teacher, by your own efforts, what happened, you'll get knowledge. So now you are here. How you get knowledge? Until unless you don't put hard work, you don't put effort, you don't analyze, not possible. Initially, you thought teacher is doing helping a lot. Now you came to that even teacher also is just teaching. Until unless I don't put effort, I'll not get a rank. I think graph is very much related to your mindset, your emotional imbalance. Okay, now what happened? You are understanding. I should put effort. Okay, teacher will do his work. Okay, if I don't put effort, I don't get rank. If I put effort, I'll get a rank. Okay, no, please do analyze all these things. Huh? The graph is very much related to your way of thinking. Until you don't open eyes and analyze, think, remember things, read, compare, not possible. Knowledge will not flow. Knowledge will not just come by remembering or gathering information. It has to be analyzed. It has to be compared. You have to put effort. So what is able to? I think I'll just put for the same temperature difference. So 60 to 50 degrees Celsius, it will take say like a 10 seconds. Now 40 to 30 degrees Celsius, it has to take more time. There's a meaning of this. Okay, this rate of cooling, able to analyze. Okay, now every time this will be a very big headache, no? Like this, I'll ask you what is the temperature of the body. Can we really take help of all this? The formulas like this? No, it'll be really very difficult to do any mathematics involved with exponential. Am I right? Anybody likes to do calculation with exponential logarithm. Not advisable, no. So therefore, what shall I do? I had to make some changes to the formula. I had to make some changes to the formula. Since the temperature difference is very small between the body and the surroundings, so we can do some approximation. This is for what graph? The curry what your mother cooks and keeps it on table. How the temperature of that curry varies with the time is what we are discussing. Finish or nothing big. Huh? Okay, let's go for modification of this formula. So what we started with this one, no? I think I'll take the formula so that will be easy for you. Yeah. This is the temperature difference. No, here instead of integration, let me take help of this formula. Oh, 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 oh. I'll get back the screen. Yeah, wait. Hope everything will be saved. Huh?